For some time now, we're treating approximations. We discussed nearest 10, nearest 100, nearest 1,000, million, and billion. And hopefully, we are going to end it today when we discuss significant figures, decimal places, and percentage error. All these are grouped under approximations. So today we have significant figures, decimal places, and the last of them all is percentage error. Significant figures. If you ask to correct your number to certain significant figures, what does it mean? E.g., if I say 1, 2, 3, 4, and I say correct it to 3 significant figures, correct to 3 SF. It means you take the first 3 numbers and call that 0. But if the immediate number is up to 5, call it 1 and add it. E.g., if I want to correct it to 3 significant figures, 3, first 3 numbers, 3 whole numbers, 1, 2, 3. The immediate number next to it is 4. 4 is not up to half. Any number from 5, 6 up to 9 are regarded as one whole number add. So if I want to correct it to 3 significant figures, I'll just take 1, 2, 3. Then what happens to the form? Most let's stop at 1, 2, 3. No. How do you correct or approximate 1,200 to only 123? It's unfair. It's mathematical. To approximate 1,234 to only 123 numbers is injustice. So if what approximate to you, what you now do, call this number 0. You know that therefore, instead of 1,234, you are now approximate to 1,330. If you like call it to the next thing, yes. So, but here, you are approximated to 3 significant figures. I must also state at the answer that correct to 3 significant figures. You must tell them what you do. Let's take another number 1, 2, 3, 5, 6 to 4 significant figures. You have to take the first 4 whole numbers. First 4 numbers. 1, 2, 3, 4. The next number, immediate number is 6. Is all to have? Yes. Call it and add it here. 1, 2, 3, 6. Call this number 0. You also say 4 SF. If I'm asked to correct 6, 7, 8, 9, 9, 9 to, let's say, 4 significant figures, 4 SF. First 4 numbers. 1, 2, 3, 4. The next immediate, next number here is 9. It's up to half. Yes, call it and add it here. 1 plus is 0, 9, 7, 6. Then what happens to the call them 0? Don't just throw them away. That's 4 significant figures. That's significant figures. Quite different from decimal places. I want to make it explicit. When I go to a decimal place, the difference between significant figures and 4 places. Most of the time, why you may not find this one in OBJ. It's only as I say, write this as a correct to so. Write this as a correct to so. Now let's go to decimal places. Let's see the difference between decimal places and significant figures. Let me take your decimal places. If I'm getting 1, 2, 3, 4, 5, 6, 8, 9, and I say correct to 2 decimal places. 2 decimal places. You see, in significant figures, you start from the first number here, 1, 2, 3. But in decimal places, I repeat, you must start from the decimal point. Repeat, from the decimal point. Or like significant figures, just start from the first number here. 1, 2, 3, 4. But decimal places say you must start from the decimal point until you get a non-start. So I'm going to start from here, decimal places, because emphasis is on the decimal point. So I'm starting from the decimal point. I say count 2 numbers from the decimal point. I'm going to say 4 and 7, 4 and 8. But the next number, immediate number is 7, not to add it here. So this number 1, 2, 3.49. That's decimal places. Decimal places. Now, if I say 1, 2, 3, 1, 0, 0, 0, 6, 5 to see 3 decimal places. What happens here? 3 decimal places. We are going to start from decimal point. Where there is 0, no, it does not concern. So long you started from decimal. So I'm going to start from decimal point here. Whatever number here, count it is significant. So I'm going to 0, 0, 6. So repeat 1, 2, 3 then 0, 0, 6. But the immediate number here is up to 1, so add it here. Because 1, 2, 3.007. You also say 2 decimal places. So in effect, decimal place say you must start your counting from decimal point. Or like significant figures. I'll pick a number The same number, I'm going to correct to 3 significant figures and 3 decimal places so that you see the difference clearly. Decimal places and significant figures. If I'm giving 178.675 to 1, 3 SF, 3 significant 2, 3 decimal places. The same number. I'm going to correct to 3 significant figures and 3 decimal places. I want to explain vividly the difference between significant figures and decimal places. The significant figure means you must start from the first whole number. So I'm starting from 1, 2, 3, the first 3 numbers, because it's 3 significant figures. So I'm going to stop here. So number 1 in answer, 178.6758 to 3 significant figures. What you do is take the first 3 numbers here, and it's up to 1. Add it here, 179.00. This was another message. So correct to 3SF. Now when I the same number again, if I'm going to correct to 3 decimal places, number 2 say 3 decimal places. Now you will now start from decimal point. You don't take all these ones again. 1, 7, 8 that are not relevant here. For we're going to start from decimal point. Because I is on the decimal point. So I'll now start from here. 1, 2, 3. So this number 178.6758 correct to 3 decimal places. 1, 2, 3. The next number is 1. It's not to call it 1. Add it here. 676.178. The same answer. Almost. Now, let me give another example here. If I ask to correct this number again, correct 0.00345678 1 to 3 significant figures and 2 the same number to 3 decimal places. Here, we're talking about 3 significant figures, first 3 numbers. The 0 here, 0.00, zeros here before this number is insignificant. They are not significant. Note, all zeros before any whole number, they are not significant. The zeros here are not significant. Note. Zeros before a number are not significant. 0 or zeros. It can be more than 1. 0 or zeros before a number are not before a number are not significant. Is or are not significant. And if I mean this 0.00, these ones are not significant. So if I corrected the first one to answer number 1, correct to 3 significant figures. Significant figures here, I will now do 0.0034678. Now significant figures, let's say 3. 3, 6, yes. 3 significant figures. First number, start counting from here. All these zeros are nonsense, they are not significant. So you now start to count from 3. 3, 4, 6. This up to 1, add it here. So answer 0, you repeat the 0, 0, don't throw them away. 3, 4, 7. Correct to 3 significant figures. The same number in number 2, here, 3 significant figures. That first is on the significant numbers. All these zeros are not significant. That's why we don't start counting. We started from here, 1, 2, 3, 3 significant figures. And this ought to have added because 0.00346. Sure, this one. Now, the same number to let's now correct to 3 decimal places so that you see the difference. Correcting the same number 0.0034678 to 3 decimal places, the same number. Now start counting from decimal point. Once you get to decimal point, anything you see is relevant. So I'm going to start from this decimal point. Whether it's 0, whether it's 0 10 times, it does not concern me. So far you start from 0, that's significant. But in this significant figures, all the zeros here are not significant. Just start counting from 3. So it's only 1, 2, 3, 4 significant figures. But decimal place, you must start from decimal point. Whatever you mean, count it. I'm directed. So decimal place, I'm going to start from the point here. 1, 2, 3, stop here. Is this ought to have? No. So the answer becomes 0, 0, 3. So you now say 3 decimal places. The same number here repeated. See, at the significant figures, it is 0.00347. Because of the 3 significant figures, 3 numbers. These zeros are not significant. But in decimal place, you are starting from a decimal point here. So 00346. So take your first 3 numbers. From the point, whatever number you see, count it. As it is 0.0000678. And I said 3 significant figures. 3 decimal places. Still. Yeah, take first 3 numbers after decimal point. Start from 1, 1, 2, 3. Answer is 0.00. Do not concern. This is the direction I'm directed. What is it as I'm directed? I'm just directed to do it to 3 decimal places. So if it is 0, 0, I'm sorry. I said that this is now to 1. Add it and here becomes 1. For before you throw this away, ask yourself 0 to 5 and above, 5, 6, 7, 8, 9. These ones are up to 1. According to 1, they become 0.001. Now if I to carry the same number again, this is number, call it number 1, number 2 again. The same number to decimal place 0, 0, 0, 6, 7, 8 to 3 signal figures. See what happens. Of course, let's say 2 signal figures. You start counting from here. These zeros are not significant. If the decimal place, yes, that's significant. Count them 1, 2, 3. First 3 numbers, approximately 1 and 0, 0, 1. But for significant, these zeros are not significant. Not. You now start counting from 6, the first 2 numbers you see. 6, 7, 8. Since the 2 decimal place just 6, 7. But this 6 add it. So your answer would have been 0, 0, 0, 6, 8. Tell them 2 decimal places. So,
Okay.
that's all. Now the last stage of abbreviation will be percentage error. There are no new words here. Percentage is over 100. Error is made when there is a mistake. So I'm going to think where there is a mistake, and I'm going to convert that mistake to percentage. That's percentage error. They agree there's a mistake. Then this mistake converted to 100%. Let's say, for example, a ruler. Let's assume a ruler measures 30 cm. Let's assume the length of a ruler is 30 cm. And ask the student measure it. Out of human error, the student may not get exactly what the actual measurement is. For only God is perfect. The student may get it at 29.5 cm. Already there is a mistake. That's error. And this mistake you have made, and I say convert it to percentage. That percentage error. And let's now go. One, a ruler measures 30 cm. The teacher asks them measure it. A student measures his or her own as 29.5 cm. There's an error already. It is this error now, see, convert it to percentage. That's the idea of percentage error. Now what you now do, if you want to solve, you now start. Actual length. If I want to solve, you say actual. What is actual length? The actual length here is 30 cm. Actual length of data is 30 cm. Then what the student got in error? The measurement in error. What the student got in his or her measurement? It's a measurement in error. Equals 29.5 cm. Already that's an error, that's a mistake. Instead of 30, the actual length 30 cm, the student in his or her measurement made a mistake, that's an error, and got it 29.5. You now say, therefore, what is the error first? Therefore, error. You must put therefore there. Therefore, error equals this, the actual minus. I said actual, what it ought to be, minus the one you got in mistake, the one you got in error. Or the mistake made. I say in error, what you got in error. In error. For this particular case, it's 30 cm, and still got minus 29.5 cm. I agree with me, the difference is 0.5 cm. Now it is this error now, that's okay. We will know the error, 0.5, now convert it to percentage. I want to convert it to percentage, let's say, therefore, percentage error equals the mistake you made, that error you made. Or that error over the actual. Let's say times 100 over 1. That's the percentage error. I'll take it again. A ruler measures 30 cm. A student will ask to measure it out of human error. The student gets at 29.5 cm. And I say, solving it, I say, actual length is this, measurement in error is this, 29.5. And I say, therefore, error is the actual minus the error that student made, what he got. Now, for this particular case, 30 cm minus 29.5 cm, that is 0.5. Having known the error, and I say, therefore, convert this error to percentage. And I say, therefore, percentage error equals the error you made, that mistake you made, over what is supposed to be, times already over 1. For this particular case, therefore, we are not taking an error which is 0.5 times what ought to be 30, times already over 1. This time this is 50. Yes, 50 over 30%. Cancel. That is 1 over 2 over 3%. Error, or can be 1.67%. And that percentage error. The length of 30 cm was measured in error at 29.5 cm. What is error? The actual T minus that thing you now got in error. And the actual here is 30, minus the error, you got it in error at 29.5. Your error is now 0.5. Error is 0.5. Now see, is this error you now made? Now convert this error to percentage. And that's the percentage error. Therefore, percentage error equals the error. That mistake over what is supposed to be times over 1. For this particular case, the error is 0.5. The actual is 30 times over 1. And if we just move these two places, 50 by cancel that 1, 2 over this 2, 1, 2 over 3, it's 1.66666. That is the recurring decimal. It will not stop. So promote to 7 become 1.67%. That is the actual. Now, it could be a board too. This is example number 1. It could be a board, like the board here where you need length and breadth. You have length and breadth. This is just one length, the roller. Assume it is a board. Example number 2. As we are asked to measure a board, it's not asked to measure a board, the blackboard, maybe 12 cm by 10 cm. Now, in error, human error, maybe it gets 11.05 cm, let's say 0.95 cm, and gets maybe 10.01 cm. There are two dimensions, I have length and I have breadth. You will find what is the error in the length, what is the error in the breadth. You also come back in the third one, tripartite. What is now the error in the area? So I'm going to look for 1. What is the error in the length? 2 cm, 12 cm, but got 11.95 cm. After I say, what is the error in the breadth? Instead of 10 cm, I got 10.01 cm. Now at the end, in the area, I cannot calculate the area, length and breadth. What is now the error in the area? So I'm taking 3 dimension 1, error in length, percentage error, of course. I'm going to say percentage error in length. Also 2, percentage error in the breadth. And finally, last number 3. Now percentage error in area. I'm going to take it one by one. Starting from 1, percentage error in the length. We start, what is actual length? Number 1, actual length. Actual length here is what? 12 cm. Now what you got in error? 11.95. Now in error, it's length in error. Length in error. What you got in error equals 11.95. What is this? Therefore, you must see, therefore, the error itself equals what? This minus that, 12.00, because of the decimal place, 11.95. Subtract 10 minus 5, 9 is 0. Then 1 here, 0, 0, 0, nothing. 0.05. If I see you come back to 12 years, you come back to 12. So that is 0. The error that I've made is 0.05 error. Now convert this error to percentage. And I say therefore percentage error in length. Define it. We are not talking about the length because the error you made over the actual. Just try 12 times 100 over 1 percentage. I bring it here 0.05 12 times 100 over 1. This is my movie 2 places. That's 5 over 12. Let's see, that's 0.5 something. Go into 5 cannot. Into 54, that's 48. 20 to 20. 20 is 1. 18 to 18. About 7. 72. 672 is 7. About primarily 6%. We've got in the actual length this. the one in error, and so at the end we got that percentage error in the length is 0.416. Although this continues, I put that means that is continuous recurring decimal. So beta provide to 0.417. Now that is for length. What about the error in the breadth? Let's go for the breadth. The breadth instead of 10, the Bible mentioned 2 plus this. So let's not take error in the breadth. Let's see. Actual breadth. 10 cm. Then in error, the breadth it got is what? It's called 10.01. 10.01. Then what is error? Therefore, error, I must put therefore there. Therefore, the mistake he has made is what, whether it could be more, it could be less, the same thing. 10.01 and 10.0. 0.01. This is not there. And therefore, in conclusion, that's it. Therefore, percentage error for this. Therefore, the error now converts to percentage error equals the mistake. That mistake he made 0.01 over actual times 100 over 1. This goes in. That one is 0.001. Multiply. 10 cancel not. 10 times move this 1 plus 1 plus 0.01. That's not the error in area. Now remember in the length, got 0.417. In the breadth, because we are going to need it. In the breadth, we got 0.01. Now, we've done that of breadth area. Now, let's go to area now. What is the actual area? Before I go to error in the area. Start. Area. Actual area. Number 3. Actual area. Cost length and breadth, of course, we know. I want the length here 12 cm and the breadth is 10 cm. That is 120 cm square. Remember, area carries a square. Anyway, you want to hear area, go with a square. Or like volume that goes with cube. Now, area in error. Area in error equals the length it got is 11.95. Got 11.95 cm times the breadth got in error 10.01 cm. Let's take a calculator now. Let's see. Quickly. I have 11.95 times 10.01. Calculator says 119. 119.62 area cm square. We now see the actual area is this. The one we got in error is this. What is percentage error? Percentage error. No, this is error now. Now what is error itself, first of all? That's actual. What is error? See, therefore, error in area equals actual 120 cm square minus 119.62 cm square. 8 here, 3 here, 0.10, 0.38. Let me see, 0.10, yes, well, another. This is not it. Therefore, percentage error combined to percent. Therefore, percentage error in area, of course, you define it. Equal the 0 you observe over the actual. Actual is 120 times 100 over 1. This has the effect of when this is, so it becomes 38 over 120. Then we'll say that as 4 can go, no, 2 can go. Let's say time here because 38 divided by 120 gives us 0.366317 percentage error in area. That percentage error. That's our percentage error. One, we are given a board. The length 12, the breadth is, but in error it's 11.95 as length, and the breadth got 10.01. We converted what is error in area. That's in the length. we got it to be this. Then in the breadth alone, we got it to be this. Then the area, and I said actual area is supposed to be 120, 12 times this. But in error, what you got is 11 times, which 199. Then what is the error? The actual 120 minus give us 0.38. Then convert it to percentage, therefore percentage error equals. This mistake has been over what is supposed to be. Sorry about that, 0.3. So that's percentage error. That is percentage error. It's not much. It's not much percentage error.